So if I had to use one word to describe AI today, it would be surreal. And it's kind of hard for me to imagine that 10 years ago, AI was very much an academic endeavor, and now countries are forming national strategies around AI. What? So the AI Index is a project that aims to track the status of AI, and each year they release an annual report. Here's some quotes from this report. Compute doubling every 3.4 months. The conference NeurIPS increased over 800% in the last 8 years. Number of jobs is also going up. And so quantitatively, at least, we see that, shouldn't be surprising to people that AI is just becoming a big deal. Qualitatively, what I think is really interesting is that AI is transitioning from being in the lab to the real world. For a long time, AI was limited to relatively artificial environments, which was useful for developing methods, but now we're seeing real world deployment in ways that really impact people's lives. And I want to stress that AI, like any technology, is an amplifier. It makes what is good better and makes what is bad worse. And we really need to be aware of both sides. So let me start with the positives, the prospects. So here are some examples in which AI has been beneficial. So in the last decade, speech recognition question answerings have gone remarkably good. And now you can talk to your favorite assistant and expect some basic, though obviously not perfect, level of language understanding. And my 3-year-old is growing up thinking that talking to computers is perfectly normal. And search engines like Google have told us that enabling power comes with being able to tap into the world's rich information. And now taking one step further, these assistants allow this information to be more efficiently and naturally accessible, which could be especially useful for people who do not have the means to use a computer. So there's language barriers in the world that pose significant challenges to travelers, immigrants, businesses, minority sub-communities. And so connecting people is very valuable. So machine translation aims to overcome these barriers. Machine translation has come a long way since the 60s. And while it's far from perfect, it is really good enough for someone to get the basic gist of a document written in a different language, or to have a real-time conversation with someone speaking in a completely different language. Autonomous driving will someday hopefully be able to reduce the number of accidents and congestion, but a major challenge is to recognize what is going on in the unstructured environment, and computer vision has made a lot of progress towards recognizing these objects, but there is still headroom to be made to ensure sufficient reliability. Interesting application is visual assistive technology. So this is an example. It's called Seeing AI for Microsoft Research, which you point a camera at something and it narrates what's going on there. And so this obviously could be a game changer for the visually impaired. Auto captioning technology is the opposite, which it's also potentially very impactful, turning sound into sight. Healthcare is another big area that's growing in importance, both for diagnosis and therapeutic development, especially in areas where there is a shortage of clinical expertise. So an example of this is detecting diseases based on chest x-rays, or diagnosing diabetic retinopathy, which is one of the major challenges in AI in healthcare these days. There's also an interesting recent data set that shows images of COVID-19 cells infected, COVID-19 infected cells, and how they respond to certain drugs, with the hope that one day we can find drugs that can treat late-stage COVID-19. Poverty is a big problem in the world, but even figuring out the areas in greatest need is challenging. So recently people have been using satellite imagery to try to figure this out, because gathering survey data on the ground is very, very expensive. And using machine learning, you can look at satellite images and try to predict various wealth indicators. This could be really useful for governments and NGOs to take action and monitor the progress. So this sounds all great, right? So what's the catch? Well, there's a lot of things that one has to be aware of. I just want to give you a general idea of the space, and I'm going to go fairly quickly here. First is energy consumption. So there is a genuine cost to training high-performing models that we're seeing today. So if we look at NLP, there has been a trend of training more and more large language models. Back in 2018, which is like ancient history now, models had about 100 million parameters only. And then BERT came along, which some of you might have heard of, made a big splash with 300. And then in January this year, Microsoft released a model which was 17 billion parameters. And then to top it off, OpenAI in May released 10 times larger model with 175 billion parameters. So this is big. Last year, there was a paper published that talked about the carbon footprint of training these models. So they looked at a transformer with 200 million parameters, which would be around here on this graph. And they show that even this train, if you use neural architecture search, this was 5 times the amount of CO2 emissions in the entire lifetime of a US car. So now I'll leave you to speculate how much GPT-3, what GPT-3's environmental footprint is. So needless to say, a lot of people are actively trying to somehow reduce the model's size, improve efficiency without sacrificing accuracy. Privacy is another big area. So machine learning algorithms have really been developed to assume that data is just sitting there in one place and is fully accessible. But our mobile files generate a wealth of information, and we might not want to be sending all that information up into some big internet company. Recently, there's been a lot of active work in privacy-preserving machine learning, which allows some of the learning to be happening on device in a decentralized way and only transmitting various essential statistics to a central server. Security is another major challenge, especially in high-stakes applications like autonomous driving and face identification for authentication. So here, models not only need to be accurate, but robust against attackers and malicious behavior, which we know exists in the world. So researchers have shown that if you can adversarial examples, so if you take an image of a stop sign and you actually post these stickers on them, you can get a state-of-the-art system to think that these are speed limit signs. Or you can actually buy these cool-looking glasses that will trick Face ID to think that you're some celebrity that you're not. So guarding against these attackers, quite kind of frightening, is still a wide open problem. Bias was mentioned in the chat. This is something that's maybe less spectacular in terms of sudden impact, but I think is more pernicious. So here's an example from machine translation. If you take Hungarian and you have the words he and she, which are not differentiated, you translate them into English, so the machine translation model has to hallucinate the gender, you can reveal all sorts of stereotypes that the model is harboring. For example, she is a nurse, baker, wedding organizer, but he's a scientist, engineer, and teacher, and CEO. And there's a lot of active work showing how hard it is to actually remove these biases. So I want to say that machine learning algorithms, they are based on quote unquote objective mathematical principles, but the trained models are trained on to latch onto statistics in the data. And the data comes from society, so any biases in society are reflected in data and propagated to model predictions. And worse, sometimes they're even amplified. So here's another case study. So Northpoint is a company that produced a software called Compass that assesses whether someone is going to commit a crime again. And so ProPublica, this nonprofit organization that does some investigative journalism, came out and said, whoa, 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 you are not being fair, because given that an individual did not reoffend, Black people are twice as likely to be wrongly classified as committing a higher risk score than white people are. But Northpoint defended themselves by saying that given a risk score of 7, 60% of white people are reoffended, 60% of black people are reoffended, so therefore it's fair. So both of these actually turn out to be simply different kind of desiderata of fairness, and unfortunately, there's some actually impossibility results that say you can't have these two and a third criteria that hold for imperfect classifiers at the same time. And given that these algorithms are being actually deployed and really impacting people's lives in a huge way, this indicates that we not only need to understand the technical implications of all these algorithms, but also think about the philosophical and policy-related issues as well. So this one's kind of scary, generating fake content. Deep learning has enabled us to generate deep fakes, such as Obama saying things that he never did, which you can find online. Or more recently, this is a blog post written by our friend GPT-3 that made its way to #1 on Hacker News. So it's completely clear, at least to me, that we've lost the ability to tell the difference between real and fake content. And given the ease and scale at which fake content can now be generated, bad actors spreading disinformation is, I think, a major threat to our society. Finally, AI systems are being deployed in dynamic environments where you have systems which are making predictions, serving you search results, giving you recommendations, serving ads, and users are taking actions by clicking, essentially. And these actions are recorded as data. This data is used to retrain the system, which furthermore reinforces these actions. So I think there's a very dangerous feedback loop inherent in machine learning where all these biases are amplified and they're polarized and leads to quite unstable behavior. So I think a major open research challenge is to how to figure out how to build more robust systems that are not as susceptible to these unstable dynamics. So to conclude, I just want to stress that AI technology is an amplifier. And we've seen that AI can and promises to be quite beneficial to society, reducing accessibility barriers, improving efficiency. But on the other hand, it can generally amplify biases, introduce new security risks, centralize power in ways that was kind of unprecedented before. And I just want you to keep these issues in mind as we go through the course. Just because you can build it doesn't mean you should. And we could, if we're not careful, we could potentially build something that does more harm than good. And moreover, figuring out the best way to tread the line between positive prospects and negative risks is, I think, something that requires a deep technical understanding, especially if we are to develop novel solutions. And that's something that this course is going to equip you with. So that concludes this module.